And I'm waiting for, there we go. So I've got I can lay one over the other if I want. And so we're going to be talking a lot about the graphing calculator. And we're also going to be talking about graphing a lot today. You're going to see me do quite a bit of work in ALEKS for these problems. So let's get started. We want to talk about Objective 10 on transforming functions. Let's first talk about the parent graphs. What are the basic graphs in college algebra that we expect all students to know? So if they saw f of x equals 1 over x squared, well, what would that look like? So let's take a look at those, but let's go into ALEKS to do that. So I don't need this, I don't need that. And where you go, since I'm here, to look at, let me go back out, let me go to the home page. So this is where you are when you enter ALEKS. And where you should go to check your score in ALEKS for the test is to the gradebook. This gradebook matches my gradebook. Where you also want to go to assignments to review your test 1 problem by problem. Now, the scores in assignments are not accurate. The scores in assignments don't necessarily match my gradebook. The scores in the gradebook match my gradebook. So I hope that makes sense because that's very important to understand that. And I don't think I also want to show, I think, did I just show you in Canvas how to look at the written work grades there? I did it in my previous class, I know, but I can't remember if I did that with you. Do we need to go into Canvas too? Can somebody tell me that? Do you know how to review the grades in Canvas for written work problems only? So let me make sure that's all set up for you. Let's take a look at that real quick. So, and at the very least, we'll get it into the video. And this is this class. So let me make sure it's all set up. And let me look at the student view for a minute. And if I need to set up something really quickly, I will. Yeah, it's grades right here. Grades. Now, you're going to see zeros as your total grade, but those grades of zeros do not get transferred to ALEKS at all. The Canvas gradebook is set to 0 for a reason, because when I talked to our instructional designer in distance learning, he didn't want you all to think that these were your grades, your final grades for the test. So you want to go into grades in Canvas. The reason why you want to do that is just to review your 7 written work problems. I did not grade the rest of them. I only graded the 7 written work problems. So you want to go there to grades in Canvas to look at that. You'll probably, because I had the ability to write comments and so forth. So you want to do that. That's where you go. So let's go to ALEKS. Go back to ALEKS. I want to make sure, and I'm going to close this down just so I have less to, I'm going to sign out of this. Good housekeeping here. And let's go over to assignments in ALEKS, which is where we were. Okay, remember, this is where you go to review your test scores, but I wouldn't trust assignments for your exact grade on any assignment, including test. You want to go to the grade book for that, right here. This grade book matches my grade book. And when if you were to talk to me about your grade, I would be looking at this grade book. Well, the version I have in ALEKS, which is the same as this, what's in this grade book. So let's start. Unless anyone has any more questions about the test or about the course in general, let's get started. So when I enter ALEKS, I enter on the home page. I am going to go up to these 3 bars and go to review. I have all the topics in review mode, so I can get to them all. And I'm going to click on transform functions when I get a chance here. Right here. So let's start by looking at matching parent graphs with their equations. Now you see that ALEKS is going to give you 4 graphs for each one of these questions. You also see there's a lot of choice here for each one, all of these. F of x equals 1, f of x equals x, then x squared, x cubed, square root of x, absolute value of x, 1 over x, and 1 over x squared. We're going to talk about how you can look at do those all on your calculator too. Let's look at the explanation. In the explanation, they have all these graphs here for you down here, and they're telling you what they are. The purpose of this topic is so that you learn what functions and you learn the functions and the graphs. In other words, what does the graph of an absolute value of x, let's say, look like? It's a V-shaped graph. So you want to learn these graphs. It's very helpful to know these graphs, especially if you're going on. And you will see one of these questions. You will see this question on your next test. ALEKS is saying to memorize them. You know, I would just do enough, and it's probably a good idea to memorize them or to be able to get them quickly on the test. So your one option is to memorize, the other option is to be able to use the graphing calculator. You will see that ALEKS has their graphing calculator lined out, or their calculator lined out over here. So there are many reasons why we require students to have a graphing calculator for this course. So let's take a look at some of these. And where I want to go is down to my desktop. And I've got them right here. Let's talk about how to use the calculator to do each one of these. And I've got the calculator right here, so I can point to the buttons that we need to use. So let's quickly I want to write the ones down. I'm not going to draw the graphs. I'm just going to write the ones down that we're going to do. We don't need to do f of x equals 1. That's easy enough on the calculator. It's just a horizontal line through at y equals 1. This one's easy enough on the calculator. F of x equals x. It's a line that goes through the origin, through 0, 0, like this. We're going to look at f of x equals absolute value of x and how to get that. So grab your calculator, your graphing calculator. We want to look at this one, f of x equals square root of x. This one, f of x equals x squared. We'll just review that. And f of x equals x cubed. once you have x squared and x cubed, you should be able to, well, you've got, once you have x squared, you should be able to do 1 divided by that, just using the division symbol. And you should be able to certainly do this, 1 divided by x. So that's how you would get those. So we really have, I think, four that I would like to take a look at. So let's go back. Let me get this back here. And let's start with f of x equals the absolute value of x. So where you want to go is y equals. Let's go to y equals first. F of x means the y value at a certain x coordinate. So f of x means y, g of x means y, h of x means y. So we want to go into y equals right here, this button right here. I'm going to clear out what's there. We're going to be doing a lot with the calculator today. And so let's do, or we could do this on the home screen. It doesn't really matter. So if you're doing this on the home screen, it's going to appear on the home screen. If you're doing this in y equals, it's going to appear in y equals. So it just depends on what your need is at that particular time. Since we're graphing, let's go ahead and go into y equals so that we can get used to that what you do if for graphing. And that's what we're going to be doing. So in y1, I'm going to put in absolute. I'm going to go in there on my calculator. I've got my calculator in my hand. I was so glad that I figured out how to do this so I could show you what we're doing today and with the graphing calculator. So I want to get to absolute value. I want to write in y1 after I go inside here. I want to write in on the other side of the equal sign absolute value of x. So one of the best places to go if you don't know where to go is the math menu right here, math key. So click on the math key. I'm in y1 equals. I'm clicking on the math key now. So I clicked on the math key. And then we want to do that. And you might want to take notes, math, and I circle it. And then you will notice that you get that one. You will notice that right next to math is the word num. So to get to num, we've got a right arrow over, which means we have to use this arrow right here on the calculator. So right arrow over. And then it says abs. Well, abs, that could be remind you to work out, but it also means absolute value. So we want that. Now, abs has the 1 highlighted, so we don't have to do anything but click enter now. So I'm going to click enter. And that puts the absolute value sign just to the right of the equal sign. And then you can type inside there whatever you're wanting. It could be x, probably most likely is x. The x is right here on this button. It's got x and some Greek letters after it. So you click on that button to get the x inside. And then I would just click enter if that's all you wanted was absolute value of x. Any questions on how to get the absolute value of x? So let's now look at square root of x. I think I've talked about this, but let's talk about it again. Right here in the leftmost column, the square root is right there above a key. When you want something above a key, you want to pay close attention. And on my calculator, that's in blue. That means I want the square root, which is in blue, which means I need to click on the blue button first, which is the second key. So you want to do a second And then the square root is above the x squared. Second x squared to get the square root. So if I go down to y2 in my calculator, I'm doing second and then x squared. And I get square root. And for now, I'm just going to put x inside. There's also another way to do that. So I'm going to go down to y3 and show you that. Actually, no. Well, there is, but it's an exponent. So it's x to the 1/2. So let's skip that. Let's look at f of x equals x squared. So let's in y3 put f of x equals x squared. So I click on x, is right here. And then I use this mountain peak right here, which means exponent. It's really what it means. So I'm going to use the mountain peak, and it's more versatile because I can raise x to any power I want. It could be fractional. So x mountain peak. So I use this mountain peak here. I could raise x to the 3/4 power, for example. I mean, I could do whatever I want there. It's got a lot built into it. Instead of having to find a special place for every little different exponent, which the calculator doesn't provide everyone, of course. But I use this because it's more universal. So now after I put in x, I clicked on this. So we're doing x squared now. And I get x. I click on that, and then I click on, since I've got my exponent box, I'm putting in 2. So I now have in y3 x squared. So then let's do x cubed. And just to show you the versatility of this mountain peak here, let's go to x4 and put in x. And I'm just using the down arrow to get to, let's go to y4. I'm using the down arrow to get to y4. And I'm going to put in x again. And then I'm going back to this mountain peak, clicking on it. And this time I'm going to put a 3 for x cubed. Very, very, very versatile button, this mountain peak. Any questions? I mean, this is one way. If you don't want to memorize these parent function graphs that I just showed you, this is one way to get them on your calculator. That's another option for you. Any questions on those parent functions? So I'm going to have you do those. You know, it's just looking at the explanation and looking at the graphs, or getting them on your calculators. I decided to take this approach instead. Any questions about the calculator? Any questions so far that you've had in the course about the graphing calculator while I have the graphing calculator on the screen? Any questions about the graphing calculator? We're going to use it more and more. We are going to use it in one big topic that we are going to use it about. Well, I shouldn't call it a topic, but it's a group of, it's more like a chapter in the book, if you were thinking of it in terms of a book. But it is great for getting what we call zeros of polynomials, because we're going to use a t-table for that. And if you have a cubic or a quartic and you can't find a 0 to get started, it's going to be really hard for you you won't be able to get credit for those problems on a test. The alternative is make a list of possible zeros and check them all by hand. Well, I don't want to do that. We had to do that in the old days, and trust me, I don't want to do it because I had to do it so much when I was young. And so the graphing calculator is very, very important in this class. So let's just look at let's look at some information about what translating or transforming functions means. So I'm going to go back here and back up a little bit. And what we want to do is those parent functions. We want to change the numbers a little bit, like add a number, subtract a number, put a negative sign here or there to create graphs of new functions out of the parent functions. So let's talk about in objective 10, this is transforms functions. So transformations functions is a very broad topic. Translations is a subset of that very broad topic. We are going to do one transform topic in ALEKS that is not a translation, but the other graphing topics that we're going to talk about, not the parent functions, but the other ones we're going to talk about are translations. So what is a translation? When do we have a translation? And it's if each of the points on a graph is moved the same distance in the same direction, we say the graph is translated. So if all the points are going left or right or up or down, we have a translation. So let's look at those translations. So let's get started by looking at shift the graph of y equals x squared. That is a parent function right here, where y we could replace by f of x, g of x, h of x, and so forth. So how do we shift the graph of y equals x squared to get the graph of each of the following? So in y1 of our calculator, we want to put x squared. So I'm going to clear out everything I've got by using the arrow keys, and also the clear button is very helpful to know where it is on the calculator. It's right above that mountain peak, the clear button. Very helpful. So I'm going to clear out what's there. I'm going to use the up arrow, clear, up arrow, clear. So how do we shift the graph of y equals x squared to get the graph of each of the following? So in y1, I want to just put x squared. So I'm going to do x mountain peak 2. So you want to definitely be in y equals to do that, or else it'll end up on the home screen in all likelihood. So in y2, let's just put this, and let's compare the two graphs. Now, the graphing calculator, whatever you put in y1 will get graphed first. Whatever you put in y2 will get graphed second. Whatever you put in y3, if you were to do that, will get graphed third. Calculator will graph in order. So in y2, I'm typing in this. X squared, so x mountain peak 2, right arrow down to the normal line of writing, plus sign 2. And what do I get if I graph? Now before we graph, let's make sure we are all on the same page, and we do a zoom followed by the number 6. So zoom, let me just show you. Zoom is right here, right there. That's zoom. And then followed by the number 6. So if we do that, zoom 6 is going to graph the parent function first. So what happens to the parent function? Where'd it go? Where'd it go? Did it go left, right, up, or down? Where'd the parent function, where did the new graph go? So the parent function is the one that got graphed first. It's the parabola sitting on the origin, opening up. Where did the new graph go? So if you had to move the parent function graph, how would you move it? Left, right, up, or down? Can anybody tell me? How would you move it? Left, right, up, or down? So I won't attach a name to whoever answered the question. I just want I want you to participate. I think it's more fun if I'm trying to encourage participation. So what do we do to the parent graph to get the graph of y equals x squared plus 2? How do we move the graph of the parent function?
I'm still kind of confused on how we got x squared plus 2.
That was just something I chose to demonstrate. That's a good question. That's something I just chose to demonstrate what you do to the graph. So like we took y equals x squared and we wanted to change it a little bit. Okay. So I didn't want to.
Does the y? Oh,
yeah. So let me just finish what I wanted to say. So I didn't want to choose, say, x squared plus 1 because the graph would be too congested. So I just chose x squared plus 2 to see where would the graph of y equals x squared move if I just tacked a plus 2 on at the end. Does that make sense?
Yeah.
Okay. So that's what I wanted to do. So so we tack that 2 on. How does that change the graph of the parent function? And I know somebody was going to answer, so feel free to answer.
I was going to say the y-intercept goes up too.
Yes, so the graph, and every point on that graph goes up too. So that's great. Yes, every point on the graph goes up too. So to give you a picture of what we're looking at, that's the graph I got on my calculator when I did that. So the blue graph is the graph of our parent function. We added a 2 at the very end, and that's taking every point on this graph adding that 2 took every point on this graph and moved it up to 2 units. That's what's happening. So that's what that 2 does. So if you add a 2 at the end, the question is, how do we shift the graph of y equals x squared to get the graph of y2 equals x squared plus 2? What happens to this graph? It goes up 2 units. So what happens to the graph of the parent function? It goes up 2 units. So now let's go back into y equals. And let's look at y2, go down to y2 and change that plus sign to a minus sign. We still want to keep that parent function y equals x squared there. And what happens? We know the parent function is getting graphed first. So let's take a look. There's the graph of our parent function. And what happened this time? How can you move the parent? What can you do to the graph of the parent function to get the new graph? Where does it go? It goes
shifted down.
Shifted down 2 units. This number of units. Now that's kind of what you would expect, because what we're doing here is we're changing the y's. Y equals, right? We're changing the y's. So that's kind of what we expect. If you're adding 2, you're moving up the parent function graph up 2. If you're subtracting 2, you're moving the parent function graph down 2 units. This number could be anything. It could be 3, 5. If it were 100, you'd be taking the graph of the parent function and moving it up 100 units. So that's what you want to look at. So now what I want you to notice is this 2 is being added next to x squared. This 2 is being added next to x, a difference. Definitely a difference. This 2 is being subtracted from x squared. This 2, however, is being subtracted from just x. Something else you want to notice is the order of operations is different with respect to these and these. The first thing we do here, according to PEMDAS, is do we deal with the exponent first, or do we deal with the adding 2? PEMDAS, please excuse my dear Aunt Sally. We do parentheses first or any grouping symbols, but we don't really have those. And then we do exponents. So this is the first thing we're going to deal with. That's the first thing that when the calculator's plugging in all these numbers or whatever algorithm they're using, that's the first thing that they're doing. They're taking those numbers and taking them and squaring them. Taking each one of those numbers and squaring them. Whatever number they're working with, to say more precisely, whatever number they're working with at the time, they're squaring it and then adding 2. Whereas here, they're taking the number and adding 2 first and then squaring. So this is squaring, then adding. This is adding, then squaring, according to the order of operations. So there's a big difference there, really. Doesn't seem like there might be, but there is. So let's take a look at these now. Let's go back to y equals and look at this one right here. Let's definitely keep the x squared, our parent function, and in y2, type this in. I'm going to clear first. Otherwise, I get confused sometimes if I see more numbers there. X plus 2, parenthesis, Mountain Peak squared. Now what happens? Let's see.
The
Yeah, what
quadratic function moves left 2 units.
Yes, it does. It moves left 2 units. So it goes from being at an x coordinate of 0 to an x coordinate of -2.
So I have a question. Why is it when it's positive, it moves left when the left is the negative side? I've always been confused about that.
Okay, so we're going to talk about that today. And I know students have said, I can show you that right now. So let me just, so this particular graph, let's go to this particular graph here. Let me make sure I get the right one here, because these are just screenshots. So we're looking at this right now. So what are the coordinates of the vertex of that red parabola? It is -2, 0, right? So the x coordinate is -2 because it's on the x-axis there. So that's -2, comma, what is the y coordinate? Go over to the y-axis, it's 0. So let's go back to so you're asking, why is it there rather than at 2, 0?
Yes.
That's what you're asking. So let's take a look. So I wrote down both the ordered pairs, -2, 0 and 2, 0. So let's write those down. I don't think I did a very good job there. I've got to get my curve down there. It's not that easy. Let me take care of it. Let's just do this one more time. So I want, here we're asked to do this -2, 0, or I think it's a really good idea that we do this -2, 0 versus 2, 0. So we're looking at those two is basically what we're looking at. Remember, every ordered pair has to satisfy the equation. Every single one. So the question is, which one of these ordered pairs satisfies this equation? That's the question. So let me get another color here. Let's see, I think I have to choose this before I can change the color. Let's do blue. So if I take this negative 2 here, that's in the X position. That's in the X position. So we want to put negative 2 in here for X. And we want to put this 0 is in the Y position over here. So is this a true statement? So this side's just 0. This side is negative 2 plus 2, which is 0, squared, which is still 0. So we get 0 equals 0, which is a true statement. So this is the one that works. Now, just for fun, let's try the other one. So let me just, you see if I can erase these guys. It's got to be a little bit of a better way, but it may, this isn't too bad. And now let me just go and this time put 2 in for X and 0 in for Y. And let's take a look at that. So this side is just 0. This time we get 2 plus 2, which is 4, squared, which is 16. 0 equals 16 is a false statement. That's we have to go, even though our intuition probably tells us to go positive, that's why we have to go negative. We have to do the opposite. We have to go left 2 units. Does that answer your question?
Oh, yes, it does.
That's a great question. These guys up here work like you would think. If you're adding a number, you expect to go up. If you're subtracting a number, you expect to go down. These guys down here work opposite of what we would think. So that's why I've got over here, works like we think. And over here, and let me just say, also, let me point this out. I call this plus 2 here. That 2 is being added right next door to the X here. Whereas I consider this 2 being added down the street because there's a squaring process in between. This 2 is down, that's being added down the street. Down the street works like we think. Next door to the X works opposite of what we think. So the number being added or subtracted next door to X works opposite what we might think. Does that make sense? It's good. So since we've already seen what happens here, it only goes to reason, right? That if we're subtracting 2, it's going to go the opposite what we may think. But let's just try it because it's not going to take us very long. We can go to y equals, go to y2 and just change that plus sign to a minus sign and then graph. And this time it's not going to go, it's going to go right 2 units. So we're going to see this phenomena. See where the right 2 units is. We're going to see this happening. That's what happens. Goes right 2 units. And we can play the game where we write down the ordered pairs and check them. Write down the possibilities and check to see which one satisfies the equation. All ordered pairs must satisfy the equation. And we're going to see this you can get through this objective much quicker if you've got these quick checks to give you a warm and fuzzy that you've got the problem right. So that was a very timely question and a very good question, and I'm really glad you asked it. So we looked at that, and I think now it's time to jump into Alex. So let's go to Alex. I'm gonna get back into Alex here. I'm sure you've all experienced this. And I want to go to class tools and to the student view. Whoa, wait a second. I think, let me go back into my other Alex course. I think I'm gonna run in, because I don't want to run into the problem of not having all the ones that I want. So I'm going to, sorry for that, and I will go back into the one I had earlier because I had all the topics there and I was certain of it. So I want the 08 class, the one that was earlier today. Class tools, student view. And that's completely set to review, so I've got all of that. So I want to go into review mode. So I know I have all the topics available in this course. And I'm going to go and so once you learn a topic, it goes to review mode. Unless you unlearn it via a knowledge check, and then it'll go back to learn mode. But you'll be past it by then, is part of the issue. So you can talk to me about that if you wish, but let me go choose the correct objective here. And let's start from this end. And we'll work our way through. Translating the graph of a parabola, one step. So let's just do part A first and then part B, unless we want to compare and contrast them. In both part A and part B, the graph of y equals x squared is shown. In part A, translate it to get the graph of y equals x minus 4 all squared. And in part B, y equals x squared plus 2. Now in this one, the 4 is being subtracted next door to the x. That works opposite of what we think. Although maybe you think maybe you see it and it's obvious to you. Some people are probably wired like that. This one is this number is getting -4 is next door to the x. This number is not next door to the x because there's a square in between. This is what I say, this number is down the street, the opposite of next door, down the street. So it's the next door that works opposite of what we think. It's this one. So rather than going left 4, we're going to go right 4. So we're going to pick this up. So this is just drag and drop, pick this up and move this to 4 on the x-axis. Now, just to check, you can always find the vertex of the parabola that is at 4, x coordinate of 4, and a y coordinate of 0. What happens? The y coordinate is 0. And if we put so keep in mind, we've going to have 0 on this side. If we put the 4 in here, we get 4 minus 4, which is 0, and 0 squared is 0. So we have 0 on this side equals 0 on this side, which is a true statement. So that makes sense. So, and this is true for every ordered pair on the graph. Every one. Every ordered pair on this graph has to satisfy this. Or I should say every ordered pair. For this equation, every ordered pair on this graph has to satisfy this. Now, for our original graph, every ordered pair has to satisfy this. So we're done with this one. Let's do the second one. Now, this 2 has a house in between, let's say. It's down the street a little bit because it has this 2, this squared here in between. So this works like we think. So we want to go up 2. So let's take the vertex here and move it up 2. And that's what we get. Anybody have any questions on this? So let's check and see what we get. And it's correct. I think you're seeing it's important to check. I would pick the vertex for both of them and actually check it. It won't take, it's very, very quick check. And it will give you your consecutive bars quickly, in all likelihood. Especially if you're carefully checking. Any questions on this particular topic? So let's move along. Let's do this one. Translating the graph of a function, one step. Now they're giving us different functions here. Part A, it looks like they give us a quadratic. It's quadratic in nature, and part B is cubic in nature. So let's look at this, and what we've been presented with is just a little bit different. They're telling us in part A that the graph of y equals f of x is shown. Translate it to get the graph of y equals f of x minus 2. So they've given us the graph of f of x. And f of x is y. Y equals f of x, g of x, h of x. We could keep going and going and going. This really means the y value at a specific x value. That's why we label f of x with y. Translate it to get the graph of y equals f of x minus 2. And then we have the graph of y equals g of x is shown. Translate it to get the graph of y equals g of x minus 5. Well, we need to compare these two a little bit, I think, to understand what we're doing for each one. This minus 5 is right next door to the x. That works opposite of what we would think. This, on the other hand, is down the street from x. It's not next door. It's not inside like this. It's not inside the parentheses like this. It's outside the parentheses. So this outside the parentheses works like we think. Inside the parentheses works unlike we think. So this one is pretty straightforward. We're just going to take every one of the y's on the entire graph. That's what this is saying, and subtract 2 from it. That's going to go down. It's going to take every y coordinate and move it down 2. So let's do this one. This one works opposite of what we think. So we don't want to go in the negative direction 5 units. We want to go in the positive direction 5 units. So we're going to pick up this point here. And we want to go in the positive X direction, 5 units. So we are at -3. And -3, well, we have to go to, if we go to the, right here, we're 3 units. So we want to take -3 and add 5. That's really what you want to do, and you'll get +2. So you want to take this right here. Make sure you keep it the same until you get to +2. Now I want to make sure those are on the same, horizontally on the same line, so that I know I get it right. Any questions on that? So let's check. So we got it right. Any questions on this topic? Let's go back up to the carousel and move over 1 here. Now we are translating the graph of an absolute value function 1 step. And these can be out of order. You may have a horizontal shift here sometimes and a vertical one here sometimes, or it could be swapped, vertical here, horizontal here. So let's look at A, the graph of our y equals absolute value of x, a parent function is shown. Translated to get the graph of y equals absolute value of x plus 1. The 1 is being added next door to the x. This is opposite of what we think. Think of it as opposite of what we would think. So we want to go 1 in the, we don't want to add, we don't want to go to the positive x's. We don't want to add 1 really. We want to subtract 1. So we're going to go this way 1 unit. Now, if I were you, since we know what this function is, figure out what is the vertex there. That is -1, 0. I would jot it down on your paper, and I would make sure that it satisfies this. So the y coordinate of this is 0. So we're putting in 0 here, equals absolute value of the x coordinate right here is -1 plus 1. -1 plus 1 is 0. The absolute value is 0. Well, y is 0? So 0 equals 0, true statement. So next, we want to do this. The parent function is the same. Translate it to get the graph of y equals absolute value of x minus 2. Now, -2 is down the street because there's an absolute value sign in between. So this works like we think. We want to go down 2 units. Let me make sure I get it down 2 units. Now there we go. Now I would encourage you even to check this one. Maybe just double checking is important. So in this case, this is at the x coordinate straight up to the x-axis is 0, 0, -2. So you might want to check those too, that ordered pair. So our y in this case is -2. Our x is 0, so 0, the absolute value of 0 is 0. So we get, this side is -2, we get 0 here. 0 minus 2 is -2. True statement. So check. And got it right. So any questions on that? So graphing here is pretty easy in the sense that it's just dragging and dropping so far. So let's go on. Now we're going to get to 2 steps. Well, that isn't really any more work because each one of the 1-step problems had 2 different graphs. We're only going to have to do 1 graph for each of the 2-step problems. So let's look at this. So we're just going to, let's look at this problem. Below is the graph of a parent function y equals x squared. Translate it to make the graph of y equals parenthesis x plus 1, parenthesis squared, minus 4. So what's going on here is you've got one number next door to the x and one number down the street. Now we're going to put them together. That's what we're doing. We're doing them in one graph now. So you want to remember PEMDAS. Please excuse my dear Aunt Sally and make sure you're doing in all the way through college algebra, doing all of your order, using that to determine your order of operations. So certainly in this case, you know, please, that P is parentheses, it's square root, it's absolute value signs, it's cube root, it's all different kind because of the parentheses. It's got so much involved in just that P alone. It's fraction bars. I mean, there's lots and lots involved in that P. So I would think of this parentheses first. Want to look in there. X plus 1, that's next door to the X. So that works opposite of what we would think. So we want to go 1 unit, not to the right, but to the left. So I'm going to pick this up, move this 1 unit to the left. And then this minus 4 is happening down this street. So that is a vertical shift, not a horizontal shift. So it's vertical shift, and it works like we think. So I'm going to take the vertex of this new parabola and go down 4 units. I'm trying to make sure I'm staying in that correct column. Now, I would particularly check these because it's easy to get off by one grid line even when you're doing the dragging and the dropping. So I'm going to just figure out what the ordered pair is associated with this vertex down here. That is -1 for x. And then going straight over to the y-axis here, that's at -4. So plug those numbers in here. You can jot that down on your paper if you want. The y is -4. So -4 equals parenthesis x. I think it's -1 plus 1 squared minus 4. -1 plus 1 is 0. 0 squared is 0. So I get -4 equals -4. Have a warm and fuzzy, correct? And there, that's what happened. That quick checking is worth its weight in gold. It saves, in the long run, I can almost promise you it's going to save more time. It's going to give you more time. And will also deepen your understanding. So if you have any questions, please, please, please ask me. That's very important. I want to make sure you're understanding this inside, outside, upside down. I like Dr. Seuss a lot. So how about this one? Translating the graph of an absolute value function. 2 steps. So let's take a look. It's just a random problem. And here's our parent function. The graph looks like this. Translate it to make the graph of y equals absolute value x minus 5 plus 3. In that P, in PEMDAS, absolute value bars are considered grouping symbols. So we want to make sure we're doing the grouping symbols, what's inside the grouping symbols first. That means we've got x minus 5. So 5 is subtracted from x next door to x. Works opposite of what we would think. So we're not going negative, we're going positive. So we want to go positive 5 units. So pick this up and drag it to 5, 0. And then adding 3, that works, that's down the street. It's not close to x. Down the street, it's got absolute value bar in between. So that works like we would think. So we're going to go up 3. So you want to go up 3, 1, 2, 3. And again, it's wise to check. So here it would be, we want to get the ordered pair. This is at, go straight down, 5. And then to get the y coordinate straight over to the y-axis and get 3. So now what we're checking is this. We see a y. We know that that's 3, or we think it's 3. So that's 3 equals absolute value x. We think it's 5. 5 minus 5 is 0. Absolute value of 0 is 0 because absolute value is the distance between a number and 0. Well, if you have 0, the distance between 0 and 0 is still 0. So that's the reason for that. So we got 0 for this entire term equals 3. But we had 3 on this side, so 3 does equal 3. So that's a true statement. So we have a warm and fuzzy, and we check. Any questions? So let's do this one. They're not telling us what the function is here. This is a little bit trickier, so that's why I think it's coming It's coming at this point of the process. So let me take a look. I'm not sure I'm going to do the one. No, because we've seen it. Ones like that. Let me get an explanation. Let me pick something that. This square root is pretty easy to work with. I'm looking for something in particular. Yes, this will do. Let's look at this one. So this 2 here, now this is not a parent function graph. That's what makes it confusing. It's not x cubed. Well, it's not y equals x cubed. It's y equals 2x cubed. So this 2 has automatically been incorporated down here, right here. You don't have to be concerned about that 2 at all because it's in the original function. So you can ignore that 2. So we're just working with this. We're ignoring the 2. So we're looking at x plus 1 here. And then this minus 3. But we will have to consider the 2 if we were to check. That's the only time we would want to consider it. Is it when we check. So what do we do first? PEMDAS tells us we look in here. We are taking this x and adding 1 next door to it. So that works opposite of what we would think. So we are going to go this direction to the left 1 unit. And then the cube's already here, so we ignore that. We don't really deal with that. Not in this topic. And then we're subtracting 3 down the street. That works like we think, so we need to go down 3 units. So this is where it gets a little tricky. 1, 2, 3. So I'm going to make sure I check this one just to be sure, because I can't, they're too close here. They're too close. So let's check this one. This is at -1. So that x coordinate is -1. And the y coordinate straight over here, -3. So we have y, and I'm writing down -3 on my paper, equals 2, parenthesis x, I think it's -1, plus 1. I'm copying down the plus 1 from right up here, right here, parenthesis, cubed, -3. Do we get a true statement or a false statement? -1 plus 1 on the right side is 0. 0 cubed is 0. 0 times 2 is 0. That whole term is gone, and we get -3 equals -3. And that is true. So any questions? We can always go back and take a look at something. Talked about matching parent graphs, and now we want to talk about this. So this is only the only transforming problem that we're doing in a sense. Now, every one of those translating problems, we could consider a transformation if we want to. So I should precisely say this is a transformation problem that is not a translating problem. So I want to say that, and let's just go back here. So let me just show you that translations, if each of the points of a graph is moved the same distance in the same direction, we say the graph is translated. But with reflections, that's not true. So let's take a look. I first want to do a problem on paper for you to show you what kind of written work I would be looking for on a test. So let's take a look at one of those. But before I do that, you might want to copy this down, although you don't need to if you understand what I say. So this here, there's two places where the negative sign could be when we're talking about a reflection. It could be out in front of y, the negative sign, or that negative sign could be directly in front of x. Here, that negative sign is directly in front of y. Here, it's directly in front of x. So this is telling you which do you want, what do you want to change the signs on? Here the negative's out in front of the y, so you want to change all the signs on all the y coordinates. Here, the negative sign's in front of x, so you want to change the sign on all your x coordinates. That's really what's going on with reflections. So you're welcome to copy this down. This is really the only one of these we're using. In a sense, we're not doing vertical stretches or shrinks or horizontal stretches or shrinks. We did the vertical and horizontal translation, though. We just did those. So you're welcome to copy that down. If you need more time, please let me know. And let's take a look at a couple problems. Well, actually, it's one question in Alex, but there's two problems with it right there. So you will notice I looked for the negative sign in both of these, and I circled what was immediately after it. Here, it's f of x, but f of x is really y. F means find the y coordinate of the f function when x is a certain number. So it means y. Down here, the negative sign is in front of the x. So this time, it's in front of the x. Here, you're going to change, this negative means change all the signs on the y coordinates. Change it, and that's what I've got written for short, negative on all the y coordinates. Here, the negative sign is right before, immediately before the x coordinate. That's why we're going to change the sign on all the x's when we get there. Here, it's immediately before the y coordinate. That's why we're changing the signs on the y's. How do we handle these problems in Alex? Well, the strategy is you want to take all the endpoints, this endpoint, this endpoint, this endpoint, find the ordered pairs. Down here, there's only two endpoints, one right here and one right here. So let's get started here. Let's go from left to right. We want to find the ordered pairs. So we take this, get the x coordinate first, straight down to the x-axis, and that looks like it's at -7. Straight over to the y-axis at +2. +2. Next endpoint. So you want the endpoint of any line segment. A line segment here, one here. You only have to do, if it's a shared endpoint, you only have to list it once. So this endpoint right here, straight up, axis to the x-axis, get x equals -3. Straight over to the y-axis, get x is equal to -2. So this is the kind of written work I would want to see on a test, you looking at the ordered pairs, listing the ordered pairs, because I'm also testing to see if you can write down ordered pairs correctly. I've got different things I test in written work problems along the way too. So this one, I want to go straight to the straight down to the x-axis. That's going to be an x-coordinate of 0. So we get 0, and we're on the y-axis already, and that is at 1. So here we're changing the signs on just the y-coordinates. So I copied over all the x-coordinates, -7, -3, 0, right here. Now I'm ready to change the signs. This 2 is positive, becomes negative. This is -2, we change the sign to get +2. This is +1, change the sign to get -1. And now we graph. And we'll do that in a bit in ALEKS. I didn't want the graphs to be there at the same time. I wanted you to see what I was doing to get the correct written work. I wanted that to be crystal clear. So let's go down here. So we want to get the ordered pairs down here, straight up to the x-axis, -4, straight over to the y-axis, -6. Just getting my ordered pairs. Haven't done anything with them yet. Right here, up to the x-axis 4, right there. And then we need to go over to the y-axis, -2, right there. Now, what does this say? Where's the negative sign here? It's next door to the x. This works just like you would think. So we're changing the sign this time on all of the x's. So this -4 becomes +4. This +4 becomes -4. And then we just copy over the y-coordinates, -6 and -2. And the way you would deal with these in ALEKS, and we'll see this in a bit, is you would plot all of these ordered pairs, and then you would connect the dots from left to right. That's really what it is, considering the endpoints as dots. Here you would plot these, because you already have a plot of that. So you would just want to plot these newbies. Here, you want to plot the newbies, and here you want to plot the newbies and connect the dots from left to right. So let's go into ALEKS, back into ALEKS, and do this particular problem. Let's transforming the graph of a function by reflecting over an axis. Start. Make sure, okay. So we're going to do one of each. So the first thing I'm going to do is I'm going to, on my paper, write down the ordered pair for this point, and this point. So I had a student who presented written work to me. He had the original statement of the problem. I don't know if it was he or she, actually, a student presented written work, and it was just the statement of the original problem and the answer. Well, I didn't give that student any credit because I'm looking for the written work. I really don't care about the answer. I'm wanting to see if you can do the process correctly. On the other hand, on the other problems, I care about the answers, because in math and other subjects too, and in the real world, it's important to be really accurate. So that's why I do that. So let's just write down, let's go from left to right and write down the ordered pairs. So this one, I want to go straight up and get the x coordinate, which is -4, comma, straight over to get the y coordinate, which is -7. My next ordered pair from left to right is just the endpoints of the line segments, what we're after. Straight up, get 4. Straight over, get -3. And then this endpoint, straight up, get 7. Straight over, get -6. Now, what do we change the sign on here? We're changing this work like we think. We're changing, and that negative sign, which is really is right next door to the X. So we're changing the sign only on the X's. So that -4 becomes +4, comma, -7. That second ordered pair is 4, but now we have to change the sign to get -4, comma, -3. Third order pair, the X is 7. We need to change the sign to get -7, comma, -6. We then plot that second group of ordered pairs. So you can use the pencil tool. I'll use the pencil tool for graph 1, and I'll use the plot a point anywhere tool for the part B. So I can show you. I don't prefer the pencil tool. I really never use it, but I want to show you how to use it just in case you're going to use it. I want to try to ensure that you use it correctly. So the first ordered pair I want to plot is 4, -7. So X is 4. So that's 4 right there. And we want 4, -7. So 4, -7. Down here. And then I'm going to click to get a dot. Now I will tell you, and I'm going to click on the pencil to get it off my screen. I will tell you, I'm going to double check that because I don't have that warm and fuzzy about this. So I'm going to go straight up to get 4 and straight over to get -7. So I'm going to double check that. Now the next one, -4, -3. -4, -3. 1, 2, 3. So I'm going to make sure that this is, if I go up, I'm going to get -4. And if I go over, I'm going to get -3. It looks good. I'm going to click. And then the last one is -7, -6. So -7, -6. Whoops, I got off right there. And because I got off, I want to check. -7, good. -6, good. So now I'm going to connect the dots. So I'm going to use this connect the dots tool. Let's call it that. So I'm going to start from left to right. I'm going to click on this one. Click on this one. Then I'm going to go get that tool again. Click on this one because we have to connect them. Connect the dots and then click on that. Now that looks reasonable because this is on the same horizontal line as that. This is on the same horizontal line as that. So that looks reasonable. So I'm going to leave it. Any questions on how I got that new blue graph with the dots on it? So let's go do the next problem. Same methodology. Go from left to right and get the endpoints. So this is straight up, -4. Going to write down the ordered pairs. Straight over on this point here, endpoint, straight over, get -3. -3. This endpoint, straight up, get 4. Straight over, get -1. Now, which signs change? This negative sign is not next door to the X. it's next door to the G, which is acting as Y. So we're going to change the sign on the Y's this time. So I'm going to just copy over the first coordinates. And then -4, 4, yep. So now I'm going to change the sign on the Y's. So the Y in the first ordered pair I wrote down is negative. It's going to become positive. The Y in the second ordered pair is negative. It's also going to become positive. So I'm going to now plot those. I'm going to use the plot a point anywhere tool. So I'm going to type it in. -4, 3. Plot. Next one, 4, 1. Plot. Done. X out of this. And I'm going to connect the dots. Just like that. So what's happening here? If you look at this, if I take this and I flip this over the x-axis, I am going to get this. You just flip it over the x-axis, you're going to get this. This is a little harder to see, but if you take this and flip it over the y-axis, you're going to get this. So it's your answer should look very geometrical like that. Let's check. Any questions on this particular topic? So let me come back to you and let's take a look to see how much time we have left in the class. We've got about 13 minutes. Does anybody have any questions to ask about tonight's homework that's due? Any questions? Sure? Is there any topics in tonight's homework that you would like me to go over? I have some time left, or anything we talked about today that you would like me to go over. Okay, well, I don't want to, I'm going to get I'm giving you, let's say, 13 minutes to spend 13 extra minutes on your homework. So you've got 13 free minutes and please use them wisely. I want to see a lot of high objective scores from tonight's homework. So feel free to leave, but you're more than welcome to stick around and talk to me about anything that you wish. So I'm going to take attendance before you leave, so please don't let me get away with that. And let's do that. So I'm going to take a screenshot and another screenshot to get y'all. We'll have a good, oh, I've got something in right here. Let's see, is anybody, okay, we did. I just want to make sure I'm not missing anything. Okay, well, feel free to leave and also feel free to stick around if you've got a question. Take care. Have a nice weekend.
Thank you, Ms. Bear.
You're welcome. Let me turn off the recording. Leah, Brian, or Jose, do you have a question? Okay, well, I'm going to leave the conference now.